Hey, what's up, guys? We're back today with another Arduino for Kids episode. I hope you enjoy this. Today, what we're going to do is we are going to make an Arduino distance sensor using Sonar. And to do that, I'm going to need this to focus. There we go. We're going to use one of these HC SR04 sonar sensors, and as you can see, it just has 4 pins: VCC, trigger, echo, and ground. Pretty nice, pretty easy to use. So I'm going to plug it into our breadboard here, and then don't worry, we're going to come back and we're going to talk about our connections. So let's zoom in and go over all of our connections for this project as soon as I find my pointer. All right, let's go. Let's start with the Arduino. Now, from this ground pin, we're going to the blue or the ground rail. And from the 5-volt pin, we're going to the red or the 5-volt rail. Now, because we need our 5 volts up top, I've plugged a jumper wire into the red 5-volt rail here and run it up to the top. All right, so we're using a 16 by 2 LCD again, which means we need a variable resistor, a trimmer potentiometer. This is a 10K. One side goes to plus 5 volts. One side goes to ground. We'll come back to this wire later. Now, for our 16 by 2 LCD, VSS goes to ground, VDD goes to plus 5 volts, RW goes to ground, A for anode goes to plus 5 volts, K for cathode, I don't know why there's a K for cathode, goes to ground. Now over here with our SR HC04, VCC goes to 5 volts, ground, of course, goes to ground. Now, to connect our 16 by 2 LCD, we have to connect our contrast, and that's this VO pin here, and that goes back to the center pin of our potentiometer. All right, next, we're going to connect RS. Okay. Come on, you're going to go in one of the holes, aren't you? What the heck? There we go. RS goes to pin 12. And then our enable pin, E, goes to pin 11. And then just like before, we're going to skip D0 through D3. And we're going to start with D4. Which goes to pin 5 on our Arduino. And then D5 goes to pin 4. And then D6 goes to pin 3. And D7 goes to pin 2. So those are all of our connections for the LCD. Now we just have to hook up the 2 connections for the sonar sensor, a trigger pin and an echo pin. So if we come back here, we can see those. So I'm going to put the trigger pin down here on D8. and the echo pin on D7. And let's zoom out. And there you can see we are totally connected. And there's our project ready to roll. All right, let's go look at some very short code for this. Alrighty, here is the code for the Arduino Sonar distance meter. We're going to start with our two libraries, liquid crystal for the LCD and new ping for the sonar sensor. Then we need to define our trigger pin. I'm using pin 8, and our echo pin. I'm using pin 7. Then we're going to define our max distance, which in this case is 200 centimeters. Then we're going to set up our libraries by creating an instance of liquid crystal called LCD with these pins. Then we'll create an instance of new ping called sonar with these arguments. And then we'll go into our setup. Pardon me. Alright, the only real setup thing we have is LCD begin 16,2. The rest of this here just as a little print on the screen. Sonar distance meter, waits 3 seconds, and clears the screen. Here's our main loop. We're going to begin with a delay of 50 milliseconds. The minimum delay they want you to use for this particular library is 29 milliseconds, but you can make it as many as you want. 50 milliseconds will give you 20 pings per second. Then we're going to set the cursor in the upper left, and we're going to lcd.print sonar.ping.cm, and that is going to print the distance in centimeters on the first line. After that, it's going to print our units, centimeters, and blank spaces in the rest of the lines. Then we'll drop our cursor down to the second line, and we'll print sonar ping inches, and then we'll print our units as inches, and that's it. That's all there is to it. Pretty simple code, as you can see. It uses only 9% of the program memory and 7% of the dynamic memory. All right, you've seen how to set it up, and you've seen the programming. Let's give it some power and see what it's got to do, or say, or whatever. So we power it up, and apparently I need to, oh, there we go. I know it's kind of hard to see with the lights, so let me bring it up here. Get it to focus. So against the back wall of my desk there, you can see it's fluctuating. If I bring my hand in here in front of it, you can see how it works. Now it's pointing at the shelf. Pretty easy. Works pretty cool. So that's a pretty neat, simple little project for you guys. You can put it together with no trouble at all. I hope you enjoyed this. If you did, please give me a thumbs up. Feel free to like, comment, and share. And before I go, I just want to show you a new little toy I picked up. This is a remote control for the Samsung Galaxy S4, my old phone that I use as a camera for this. So I can zoom in and I can zoom out without touching the camera and whacking it. So that's pretty good. All right, I'll see you guys next time. Bye.